Hi everyone. This is Dr. K. Kannan, Assistant Professor, Department of ECE, R.M.K. College of Engineering and Technology. In this video lecture, I am going to discuss about the basics of optical fiber communication. So this optical fiber communication, it is a subject in the 7th semester ECE student. So introduction about optical fibers. The main content of this lecture video contains the following important topics. First one, the definition of the optical fiber communication, electromagnetic spectrum, then what is basic communication system, how this basic communication system is converted into optical fiber communication system, then why the optical fiber technology is needed, then what is the evaluation of optical fiber technology, then advantages of optical fiber communication, then applications, and finally I will conclude this lecture video by telling about the disadvantages. First of all, what is optical fiber communication? Optical fiber communication is a method or technique in which the information is transmitting from one place to another place by the use of light traveling through optical fiber. Here, the optical fiber acting as a medium. So, by using optical fiber as a medium, the light wave is transmitting from one place to another place. So that is called optical fiber communication. So the communication taking place by using the medium is called optical fiber. Then, so optical fiber. So when we talk about the optical fiber, the another name of optic is called light. So what is light? Now look at the picture. You can see that whether light is present or whether it is, or if it is not is there, then how it is looks like we can see. So then what is light? So what is light? As we all know that it is a form of energy which helps to see the things, right? It is a form of energy. Then what is light? So based on the concept of light, so light may be a particle. This was first advocated by Sir Isaac Newton. Then after that, in 19th century, Albert Einstein reviewed the view. So he argued that the light, that properties such as the reflection and refraction of light could only be explained if the light wave is made up of particles. So instead of matter, the light wave was an energy. Then the Fresnel, Young and Maxwell came and they investigated about the light, and finally they told us light it is a form of a wave. Then Einstein proposed that light is actually made up of tiny packets of energy that travels or propagate like a wave. So finally they concluded that light it is in the form of electromagnetic wave. Then we see about the electromagnetic spectrum. So when we talk about the spectrum, means it is a frequency range that related to the wavelength. So now from the lower end to higher end, from 10 power 0, that is from hertz to 10 power 20 hertz. So when we talk about the lower end, that is 10 power 6 hertz, that is coming under radio wave communication. Then from 10 power 8 to 10 power 11, it is a microwave communication, and from 10 power 11 to 10 power 14, it is the infrared, the another infrared communication. Then we have ultraviolet. Then from 10 power 16 to 10 power 22, x-ray, and from 22 to beyond 20 10 power 24, it is a gamma ray. Now, the communication of optical fiber contains the range in the form of visible light. So, visible light, or we can say that ultraviolet, it is coming under the frequency of 10 power 14 to 10 power 15 hertz. Now, we can find out the different frequency range, the application. So, from 10 power 4 to 10 power 5 or 5.5 is coming under maritime, right? Maritime technology. Then from 10 power 6, it is AM radio. So this AM radio and maritime and all, they are using the medium, say twisted pair cable or coaxial cable. Then FM video, so FM radio and television. The next one, 10 power 9 to 10 power 11, to satellite communication and terrestrial communication, that and all coming under ultra high frequency, super high frequency. Then when you are extending this one from 10 power 14 to 10 power 15, this is a optical fiber frequency in terms of terahertz. So this is a electromagnetic spectrum representation from lower frequency to higher frequency. Then the electromagnetic spectrum, we can have different wavelength in terms of nanometer. So as we all seen in the previous slide, we have many number of frequencies based on the applications. Here we are going to concentrate more on visible light spectrum. So visible light spectrum starts from 700 nanometer to 400 nanometer. Actually, different wavelength contain different color. So based on the wavelength, the spectrum contains different color from 400, 450, 475, 550, 580, 600 and 700 nanometer. This all about called as the electromagnetic spectrum in the form of visible light. The next one, optical fiber operational wavelength. So what is the wavelength range? So all our optical operational wavelength is there in infrared region. So infrared region, it starts from 850 nanometer to 1625 nanometer wavelength. So 850 to 1300 nanometer, where we can have the multimode optical operation window, and from 1310 nanometer to 1625 nanometer, that support for single mode operation. So based on the fiber modes that we will see later. So according to this one, the light used as a carrier to carry the signal from one place to another place by using optical fiber in the form of electromagnetic wave with a wavelength of 1 micrometer with the frequency about 300 terahertz. Then, what are all the optical wavelength range? That is, from optical operational wavelength starts from, as I told you, from 850 nanometer to 1625 nanometer. So these wavelengths cannot support all the fibers, right? So each and every wavelength region can support different type of fiber communication. For example, 850 nanometer support multimode fiber, 1310 nanometer support multi and single mode fiber, that is multimode and single mode fiber. Then 1550 nanometer, it supports single mode long haul and transoceanic fiber, and 1625 nanometer proposed for the in-service monitoring. So different wavelength window support different modes of fiber according to their wavelength. Then, then we are going to talk about what is the communication and what is the difference between normal communication to the optical fiber communication. So as we all know that the communication is a form of information exchange between transmit to the sender or between two nodes or between two persons. So that is called communication. Then when you go for the telecommunication, the exchange of information for a longer distance based on the type of equipment. So the simple diagram shows that information is sending to the receiving end by using a medium is called a transmitter in the transmitter side, and in the receiver side, and in between the transmitter and receiver there is a link is called a transmission medium. Okay, so generally there are three basic types of information to be exchanged between transmitter and receiver. There are three forms, that is voice, video and data. And here the information is carried, right? The information is carried from the transmitter to the receiver in the form of electromagnetic carrier. So electromagnetic carrier having different frequency range from hertz to megahertz and megahertz to terahertz. According to our optical fiber communication, it is in the form of terahertz. Then you can see the basic optical fiber communication system, because we know that the communication is taking place between transmitter and receiver with a simple hardware or simple block diagram. But when you are going for the optical fiber communication, we need some extra components going to added in between transmitter and receiver. You can see the optical fiber communication system. So where we have transmitter side and the receiver side. So the transmitter and the receiver side contain first one, after getting the information from the information source, it is given to optical source by converting electrical into optical conversion, so electrical transmit. So in the optical source emit optical signal, that optical signal is communicated or forwarded to the optical detector through optical fiber cable. So here the optical fiber cable acting as a medium. Then from the optical detector, that optical signal is transferred to electrical device, where the optical signal is converted to electrical form. Then this electrical signal received by the receiver in the destination side. So this is our general optical fiber communication. So from the transmitter side to the receiver side, the electrical signal is converted into optical. Then this optical signal carried by the optical fiber as a medium. Then in the receiver side, again this optical signal is converted to electrical signal. This electrical signal received by the receiver, which is there in the destination. So this is our general optical fiber communication system. Now you can understand that what is the difference between normal communication system and optical fiber communication system. Okay, now look at that. In the transmitter, the electrical signal is converted into optical energy E bar O using optical sources. So where the conversion taking place by using the optical modulation. So optical modulation here mainly we are going to talk about light, so that it is a intensity modulation. Then the transmission medium, it is modulated optical signal transmitted to the receiver through optical cable or optical fiber. Then the receiver side, the optical signal is reconverted into electrical signal by using demodulation. Again, it is intensity demodulation before sending to the destination. Then what is the need? Why we go for optical fiber technology? So in the previous the scenario, or we can have during a past 3 to 4 decades, the dramatic changes in the electronic communication industry, because many number of applications, right? Many number of applications, many number of improvement and updation in the technology, so that many number of users they are using the internet. So we need to increase the bandwidth. That is the main criteria. So when you go for more number of users, mean then we need a larger capacity. So larger capacity, and we have to give the solution for all the end users. Okay, so to get the output for this one, we can go for the lightweight technology. It is a suitable one. So the lightweight technology, it is a technology route for achieving this ever increasing goal. So ever increasing goal, the sense we can have larger capacity, we need more bandwidth. So the most cost effective way to move huge amount of information for voice, video and data, right? Then so when you are going for the more number of users, if they are using the internet, then we need a capacity. So we need capacity and more capacity. So the technical revolution in communication industry to explore for larger capacity, then high quality and economical system for communication at a global level. So the already existing radio waves and terrestrial microwave systems have long since reached their capacity. Then satellite communication system can provide at best only a temporary relief to the ever increasing demand. This will not give long term, or it is a permanent solution. So here the extremely high initial cost is needed for the satellite communication system. Then geometry of suitable orbits, then the available micro frequency only we can use for the allocation and sharing the information, or sharing the bandwidth. So what is the next option? So ultimate option for to achieve this one, to get to occupy more number of users and to increase the capacity, is ultimate the solution is optical fiber communication. Okay, so how the optical communication satisfies the current need. So the information carrying capacity of the communication system is directly proportional to its bandwidth. So it is C equal to bandwidth is multiplied by the logarithm of 1 plus SNR. So SNR to signal to noise ratio. So look at that, the bandwidth and capacity is directly proportional. So if you are going for no more number of bandwidth, then we can have more capacity. That is the ultimate aim. So wider the bandwidth, the greater its information carrying capacity. So theoretically, when we talk about the bandwidth is a 10% of higher frequency range. So now look at that, the comparison, the signal carrier and the bandwidth. When you go for a very high frequency radio system, that is 100 megahertz, but the bandwidth is needed is 10 megahertz. Then when you go for microwave system, 10 gigahertz, and where we can have 1 gigahertz. Then light wave system, 10 power 15 hertz to 10 power 6 gigahertz, then where the bandwidth needed is 10 power 5 gigahertz. So system with the light as a carrier, excessive bandwidth we can achieve. That is in terms of terahertz the bandwidth. So to meet the present communication, we need the higher capacity device or higher capacity communication system. So that is equal to optical fiber communication. Then the need of optical fiber communication. Now look at that graph during 1850. 1850, where we can have telegraph signal started. There is no much needed for bandwidth into product BL, and 1900 telephone came to came to the existing, and where 10 power 3 was needed. Then during 1950 microwave coaxial cable and microwave came and exist, and there they need BL is 10 power 6, then light wave technology, and finally optical amplifiers. So where we have BL, it is 10 power 12. Then what is the timeline? What is the fiber optic technology growth from the starting, right? Where 1951 light transmission was done by the bundle of fibers, flexible fiber scope used in the medical field only. Then during 1957, first fiber optic endoscope came into picture, and that was used for the patient, that is only in medical field. Then 1960 the laser was invented, so they developed. Then 1966 Charles Cow the proposed cladded fiber cables with lower losses as a communication medium. That was the first introduction about the cladded fiber, where the losses is very less during 1966. Then 1970 Corning glass and developed fiber with losses below 20 decibel per kilometer. Then 1972 the first semiconductor laser diode was came into exist, and working with room temperature. The 1977 Los Angeles and AT&T Chicago, they sent live telephone signal through fiber optic at the wavelength of 850 nanometer only for the 9 kilometers by using multimode fiber. That was the first world fiber optic link during 1977. The 1980s second generation system came, and same year third generation came. So the main difference between second generation and the third generation is, second generation they used 1300 nanometer single mode fiber with 0.5 dB per kilometer, that is a loss. Then third generation they shifted into higher value, that is for 1550 nanometer with less loss, that is 0.2 dB per kilometer, where they used fiber amplifier, RBM doped fiber amplifier. The data rate it is 5 gigabytes per second during third generation. The 1993, there are 10 billion bits per second they transmitted through fiber for the longer distance, that is to 20,000 kilometer, by using the technologies called wavelength division multiplexing and the soliton pulse. The 1996 Bell Labs they used to send trillion bits per second with very low loss. So during 2000, towards achieving terabits per second data transmission was they communicated terabits per second, and they received the data with very low loss, that is 0.2 dB per kilometer. So this is about the fiber optic timeline from the starting from 1951 to 2000. Then this is the evaluation graph of optical fiber. When you look into this graph, then you can easily understand during 1975 first generation came, and 1980 second generation came with the capacity of 10 power 2, and 1985 third generation, 1990 double the every year, and now 1990 is fourth generation. So like that, from 1975 to 1990 there are more evolution in the optical fiber communication. Similarly for long distance communication with the single mode fiber, so when we go for single mode fiber, the loss is very low, so that they achieved 0.2 dB per kilometer. Then the history of fiber optic communication, as again, so the first generation during 1975, the fiber optic communication system was operated with the length of around zero point 0.8 micrometer and used gallium arsenide semiconductor laser. Then the operated bitrate of the system, where the data rate it is 45 megabits per second only within 10 kilometer. Then the second generation, during the early of 1980s, the fiber optic communication system was operated at the length of wavelength at 0.13 micrometer, where they used indium gallium arsenide phosphide semiconductor laser. Then they operated bitrate of a system up to 1.7 GB per second with the repeater spacing. Then the third generation, the fiber optic communication systems was operated at the length of wavelength around 1.55 micrometer. They used a dispersion shifted fiber. Then the operated bitrate of the system was commercially it is 2.5 gigabits per second with the repeater spacing in excess of 100 kilometer. Then the fourth generation came into picture, where they used 14 terabits per second data transmission by using optical fiber amplification. Then the fifth generation, the important technique came into picture, that is wavelength division multiplexing. So wavelength division multiplexing used to combined more than one signal, and they did multiplication, then they standard with single fiber optic cable. Then what are all the main advantages of optical fiber communication? So the main advantage, it is a larger bandwidth. Bandwidth size is in terms of terahertz. Then the small size and weight, very less weight and smaller size. Then it is mainly, it is isolated from the electrical behavior. Then immunity to interference and crosstalk. Then more securely we can transmit a signal from one place to another place, more signal security. And the transmission loss is very less, 0.2 dB per kilometer. Then the system is so reliable, and the maintenance is so easy compared to other cable like coaxial cable or copper cable. Then rigidness and flexibility, and finally low cost, and it is available very easy. Then the larger transmission capacity, so we can transmit a longer distance with more number of capacity. Then the attenuation is very less, 0.2 dB per kilometer. Then the amplification is very simple, and ultimately the cost is very low. Then lightweight of the system and high speed in terms of terahertz, better reliability and greater bandwidth, and the interference is very negligible, so no interference, and we can go for longer distance. Then application of fiber optic communication system is a telephone signal transmission, internet communication, and a nuclear radiation, to detect the nuclear radiation inside the turbine or inside the nuclear reactor. Then cable television signal transmission, medical diagnosis, and military applications. Not only this, we can have more number of applications in all the fields where we can have the higher temperature region, so that we can use optical fiber as a medium to measure all the signals. Then definitely all the system contain their own disadvantages. So here the disadvantages of fiber optic communication system is the cost of initial cost is very high. Then when you go for the joining or the find out the problem inside a fiber, it is somewhat difficult. Then next one, to measure or to find out the difficult to find out the error in the fiber, so the testing equipment is we need to have special machine, so to find out the any fault or any signal dispersion inside the fiber, we need a special testing equipment. So that is the disadvantages of optical fiber communication. Then we go for summary. So in this video lecture, we have seen a definition of optical fiber communication, and what are all these spectrum of optical fiber communication. Then what is the wavelength, what is the starting wavelength, and what is the ending wavelength. Then how the communication system is different from optical fiber communication. Then what is the optical fiber technology. Then what is the evaluation of the optical fiber technology from 1950 to 2000. Then the history of fiber communication. Then next, advantages and application, and finally concluded with disadvantages. So thank you for watching this video. Thank you one and all.